Muhammad Abdus Salam, the 29th of January 1926 to the 21st of November 1996, was a Pakistani theoretical physicist. He shared the 1979 Nobel Prize in Physics with Sheldon Glashow and Stephen Weinberg for his contribution to the electroweak unification theory. He was the first Pakistani and the first Muslim from an Islamic country to receive a Nobel Prize in Science and the second from an Islamic country to receive any Nobel Prize, after Anwar Sadat of Egypt. Salam was scientific advisor to the Ministry of Science and Technology in Pakistan from 1960 to 1974, a position from which he played a major and influential role in the development of the country's science infrastructure. Salam contributed to numerous developments in theoretical and particle physics in Pakistan. He was the founding director of the Space and Upper Atmosphere Research Commission, SUPARCO, and responsible for the establishment of the Theoretical Physics Group, TPG. For this, he is viewed as the scientific father of this program. In 1974, Abdus Salam departed from his country in protest after the Parliament of Pakistan passed unanimously a parliamentary bill declaring members of the Ahmadiyya Muslim community, to which Salam belonged, non-Muslim. In 1998, following the country's Chagai-I nuclear tests, the government of Pakistan issued a commemorative stamp, as a part of Scientists of Pakistan, to honor the services of Salam. Salam's notable achievements include the Patti-Salam model, magnetic photon, vector meson, grand unified theory, work on supersymmetry and, most importantly, electroweak theory, for which he was awarded the Nobel Prize.
Salam made a major contribution in quantum field theory and in the advancement of mathematics at Imperial College London. With his student, Riyazuddin, Salam made important contributions to the modern theory on neutrinos, neutron stars and black holes, as well as the work on modernizing quantum mechanics and quantum field theory. As a teacher and science promoter, Salam is remembered as a founder and scientific father of mathematical and theoretical physics in Pakistan during his term as the chief scientific advisor to the president. Salam heavily contributed to the rise of Pakistani physics within the global physics community. Up until shortly before his death, Salam continued to contribute to physics, and to advocate for the development of science in third world countries.
Abdus Salam was born on 29 January 1926 in Jhang, British Punjab, present-day Punjab, Pakistan, into a Punjabi Ahmadi Rajput family. His grandfather, Gul Muhammad, was a religious scholar as well as a physician, and his father Chowdhury Muhammad Hussain was a minor educational official and a teacher. Abdus Salam's father was stationed in a poor farming district in Jhang, where Abdus Salam spent his early years. His birthplace is often given as Jhang, but he was, in fact, born in Saktokdas in the Sahiwal district, where his mother Hajira Begum's family was living, and where she returned to give birth, as was customary with the first child. His sister was also born in Saktokdas, whereas his 6 brothers were all born in Jhang. The name Chowdhury Muhammad Hussain gave his son was Abd al-Salam, which means, servant of God. Abd means servant and Salam is one of the 99 names of God in the Quran. In English, his name is usually transliterated as Abdus Salam, which should be understood as a single given name. His father followed the custom of not giving a surname. Later in his life he added Muhammad to his name. Salam very early established a reputation throughout Punjab for outstanding brilliance and academic achievement. At age 14, Salam scored the highest marks ever recorded for the entrance examination at the Punjab University. He won a full scholarship to the Government College University of Lahore. Salam was a versatile scholar, interested in Urdu and English literature in which he excelled. After a month in Lahore, he went to Bombay to study. In 1947, he came back to Lahore. He received his M.A. in mathematics from the Government College University in 1946. That same year, he was awarded a scholarship to St. John's College, Cambridge, where he completed a BA degree with double first-class honors in mathematics and physics in 1949. In 1950, he received the Smith's Prize from Cambridge University for the most outstanding pre-doctoral contribution to physics. After finishing his degrees, Fred Hoyle advised Salam to spend another year in the Cavendish Laboratory to do research in experimental physics, but Salam had no patience for carrying out long experiments in the laboratory. Salam returned to Jhang and renewed his scholarship and returned to the United Kingdom to do his doctorate. He obtained a PhD degree in theoretical physics from the Cavendish Laboratory at Cambridge. His doctoral thesis titled, Developments in Quantum Theory of Fields, contained comprehensive and fundamental work in quantum electrodynamics. By the time it was published in 1951, it had already gained him an international reputation and the Adams Prize. During his doctoral studies, his mentors challenged him to solve within 1 year an intractable problem which had defied such great minds as Paul Dirac and Richard Feynman. Within 6 months, Salam had found a solution for the renormalization of meson theory. As he proposed the solution at the Cavendish Laboratory, Salam had attracted the attention of Hans Bethe, J. Robert Oppenheimer and Dirac. After receiving his doctorate in 1951, Salam returned to Lahore at the Government College University as a professor of mathematics where he remained till 1954. In 1952, he was appointed professor and chair of the Department of Mathematics at the neighboring University of the Punjab. In the latter capacity, Salam sought to update the university curriculum, introducing a course in quantum mechanics as a part of the undergraduate curriculum. However, this initiative was soon reverted by the vice-chancellor, and Salam decided to teach an evening course in quantum mechanics outside the regular curriculum. While Salam enjoyed a mixed popularity in the university, he began to supervise the education of students who were particularly influenced by him. As a result, Riazuddin remained the only student of Salam who had the privilege to study under Salam at the undergraduate and postgraduate level in Lahore, and postdoctoral level in Cambridge University. In 1953, Salam was unable to establish a research institute in Lahore, as he faced strong opposition from his peers. In 1954, Salam took fellowship and became one of the earliest fellows of the Pakistan Academy of Sciences. As a result of 1953 Lahore riots, Salam went back to Cambridge and joined St. John's College, and took a position as a professor of mathematics in 1954. In 1957, he was invited to take a chair at Imperial College, London, and he and Paul Matthews went on to set up the Theoretical Physics Group at Imperial College. As time passed, this department became one of the prestigious research departments that included well-known physicists such as Stephen Weinberg, Tom Kibble, Gerald Guralnick, C.R. Hagen, Riazuddin, and John Ward. In 1957, Punjab University conferred Salam with an honorary doctorate for his contribution in particle physics. The same year, with help from his mentor, Salam launched a scholarship program for his students in Pakistan. Salam retained strong links with Pakistan, and visited his country from time to time. At Cambridge and Imperial College he formed a group of theoretical physicists, the majority of whom were his Pakistani students. At age 33, Salam became one of the youngest persons to be elected a Fellow of the Royal Society (FRS) in 1959. Salam took a fellowship at the Princeton University in 1959, where he met with J. Robert Oppenheimer and to whom he presented his research work on neutrinos. Oppenheimer and Salam discussed the foundation of electrodynamics, problems and their solution. His dedicated personal assistant was Jean Buckley. In 1980, Salam became a foreign fellow of the Bangladesh Academy of Sciences. Early in his career, Salam made an important and significant contribution in quantum electrodynamics and quantum field theory, including its extension into particle and nuclear physics. In his early career in Pakistan, Salam was greatly interested in mathematical series and their relation to physics. Salam had played an influential role in the advancement of nuclear physics, but he maintained and dedicated himself to mathematics and theoretical physics and focused Pakistan to do more research in theoretical physics. However, he regarded nuclear physics, nuclear fission and nuclear power, as a non-pioneering part of physics as it had already happened. Even in Pakistan, Salam was the leading driving force in theoretical physics. With many scientists he continued to influence and encourage to keep their work on theoretical physics. Salam had a prolific research career in theoretical and high-energy physics. Salam had worked on theory of the neutrino, an elusive particle that was first postulated by Wolfgang Pauli in the 1930s. Salam introduced chiral symmetry in the theory of neutrinos. The introduction of chiral symmetry played a crucial role in subsequent development of the theory of electroweak interactions. Salam later passed his work to Riazuddin, who made pioneering contributions in neutrinos. Salam introduced the massive Higgs bosons to the theory of the Standard Model, where he later predicted the existence of proton decay. In 1963, Salam published his theoretical work on the vector meson. The paper introduced the interaction of vector meson, photon-vector electrodynamics and the renormalization of vector meson's known mass after the interaction. In 1961, Salam began to work with John Clive Ward on symmetries and electroweak unification. In 1964, Salam and Ward worked on a gauge theory for the weak and electromagnetic interaction, subsequently obtaining SU2 times U1 model. Salam was convinced that all the elementary particle interactions are actually the gauge interactions. In 1968, together with Weinberg and Sheldon Glashow, Salam formulated the mathematical concept of their work. While in Imperial College, Salam, along with Glashow and Jeffrey Goldstone, mathematically proved the Goldstone's theorem, that a massless spin-zero object must appear in a theory as a result of spontaneous breaking of a continuous global symmetry. In 1967-8, Salam and Weinberg incorporated the Higgs mechanism into Glashow's discovery, giving it a modern form in electroweak theory, and thus theorized half of the Standard Model. In 1968, together with Weinberg and Sheldon Glashow, Salam finally formulated the mathematical concept of their work. In 1966, Salam carried out pioneering work on a hypothetical particle. Salam showed the possible electromagnetic interaction between the magnetic monopole and the C violation, thus he formulated the magnetic photon. Following the publication of PRL symmetry breaking papers in 1964, Stephen Weinberg and Salam were the first to apply the Higgs mechanism to electroweak symmetry breaking. Salam provided a mathematical postulation for the interaction between the Higgs boson and the electroweak symmetry theory. In 1972, Salam began to work with Indian-American theoretical physicist Jogesh Patti. Patti wrote to Salam several times expressing interest to work under Salam's direction, in response to which Salam eventually invited Patti to the ICTP seminar in Pakistan. Salam suggested to Patti that there should be some deep reason why the protons and electrons are so different and yet carry equal but opposite electric charge. Abdus Salam returned to Pakistan in 1960 to take charge of a government post given to him by President Ayub Khan. From her independence in 1947 after the partition of India, Pakistan has never had a coherent science policy, and total expenditure on research and development was only 1.0% of Pakistan's GDP. Even the Pakistan Atomic Energy Commission headquarters was located in a small room, and less than 10 scientists were working on fundamental physics concepts. Salam replaced Salamuzaman Siddiqui as the science advisor, and became first member technical of PAEC. Salam expanded the web of physics research and development in Pakistan by sending more than 500 scientists abroad. In 1961 he approached President Khan to set up the country's first national space agency. Thus on 16 September 1961 the Space and Upper Atmosphere Research Commission was established, with Salam as its first director. Before 1960, very little work on scientific development was done, and scientific activities in Pakistan were almost diminished. Clarify, Salam called Ishfaq Ahmad, a nuclear physicist, who had left for Switzerland where he joined CERN, back to Pakistan. With the support of Salam, PAEC established PAEC Lahore Center 6, with Ishfaq Ahmad as its first director. In 1967, Salam became a central and administrative figure to lead the research in theoretical and particle physics. With the establishment of the Institute of Physics at Quaid-e-Azam University, research in theoretical and particle physics was engaged. Under Salam's direction, physicists tackled the greatest outstanding problems in physics and mathematics, and their physics research reached a point that prompted worldwide recognition of Pakistani physicists. From the 1950s, Salam had tried establishing high-powered research institutes in Pakistan, though he was unable to do so. He moved PAEC headquarters to a bigger building, and established research laboratories all over the country. On the direction of Salam, Israt Hussain Usmani set up plutonium and uranium exploration committees throughout the country. In October 1961, Salam traveled to the United States and signed a space cooperation agreement between Pakistan and U.S. In November 1961, the U.S. National Aeronautics and Space Administration (NASA) started to build a space facility, Flight Test Center (FTC) at Sanmiani, a coastal town in Baluchistan province. Salam served as its first technical director. Salam played an influential and significant role in Pakistan's development of nuclear energy for peaceful purposes. In 1964, he was made head of Pakistan's IAEA delegation and represented Pakistan for a decade. The same year, Salam joined Munir Ahmad Khan, his lifelong friend and contemporary at Government College University. Khan was the first person in the IAEA that Salam had consulted about the establishment of the International Center for Theoretical Physics (ICTP), a research physics institution, in Trieste, Italy. With an agreement signed with IAEA, the ICTP was set up with Salam as its first director. At IAEA, Salam had advocated the importance of nuclear power plants in his country. It was due to his effort that in 1965, Canada and Pakistan signed a nuclear energy cooperation deal. Salam obtained permission from President Ayub Khan, against the wishes of his own government functionaries, to set up the Karachi nuclear power plant. Also in 1965, led by Salam, the United States and Pakistan signed an agreement in which the U.S. provided Pakistan with a small research reactor (PAR-I). Salam had a long-held dream to establish a research institute in Pakistan, which he had advocated for on many occasions. In 1965 again, Salam and architect Edward Durrell Stone signed a contract for the establishment of the Pakistan Institute of Nuclear Science and Technology (PINSTECH) at Nilore, Islamabad. In early 1961, Salam approached President Khan to lay the foundations of Pakistan's first executive agency to coordinate space research. By executive order on 16 September 1961, the Space and Upper Atmosphere Research Commission (SUPARCO) was established with Salam founding director. Salam immediately traveled to the United States, where he signed a space cooperation agreement with the U.S. government. In November 1961, NASA built the Flight Test Center in Baluchistan province. During this time, Salam visited the Pakistan Air Force Academy where he met with Air Commodore Brigadier General Władysław Turowicz, a Polish military scientist and an aerospace engineer. Turowicz was made the first technical director of the Space Center, and a program of rocket testing ensued. In 1964, while in the U.S., Salam visited the Oak Ridge National Laboratory, and met with nuclear engineers Salim Mehmud and Tariq Mustafa. Salam signed another agreement with the NASA which launched a program to provide training to Pakistan's scientists and engineers. Both nuclear engineers returned to Pakistan and were inducted into SUPARCO. Salam knew the importance of nuclear technology in Pakistan, for civilian and peaceful purposes. But, according to his biographers, Salam played an ambiguous role in Pakistan's own atomic bomb project. As late as the 1960s, Salam made an unsuccessful proposal for the establishment of a nuclear fuel reprocessing plant, but it was deferred on economic grounds by Ayub Khan. According to Rahman, Salam's influence in nuclear development was diminished as late as 1974, and he became critical of Bhutto's control over science. But Salam personally did not terminate his connection with the scientists working in the theoretical physics division at PAEC. As early as 1972–73, he had been a great advocate for the atomic bomb project, but subsequently took a stance against it after he fell out with Bhutto over the Second Amendment to the Constitution of Pakistan, which declared the Ahmadiyya denomination to be non-Islamic. In 1965, Salam led the establishing of the Nuclear Research Institute, PINSTECH. In 1965, the Plutonium Pakistan Atomic Research Reactor (PARI) went critical under Salam's leadership. In 1973, Salam proposed the idea of establishing an annual college to promote scientific activities in the country to the chairman of PAEC, Munir Khan, who accepted and fully supported the idea. This led to the establishment of the International Nathiagali Summer College on Physics and Contemporary Needs (INSC), where each year since 1976 scientists from all over the world come to Pakistan to interact with local scientists. The first annual INSC conference was held on advanced particle and nuclear physics. Abdus Salam was a very private individual, who kept his public and personal lives quite separate. 7. He married twice, first time to a cousin, the second time as well in accordance with Islamic law. 105–106. At his death, he was survived by 3 daughters and a son by his first wife, and a son and daughter by his second, Professor Dame Louise Johnson, formerly Professor of Molecular Biophysics at Oxford University. 2 of his daughters are Anisa Bushra, Salam Bawa and Aziza Rahman. Salam was an Ahmadi, who saw his religion as a fundamental part of his scientific work. He once wrote that, "The Holy Quran enjoins us to reflect on the verities of Allah's created laws of nature. However, that our generation has been privileged to glimpse a part of his design is a bounty and a grace for which I render thanks with a humble heart. During his acceptance speech for the Nobel Prize in Physics, Salam quoted verses from the Quran and stated, "Thou seest not, in the creation of the All-Merciful any imperfection, return thy gaze, seest thou any fissure? Then return thy gaze, again and again. Thy gaze comes back to thee dazzled, weary." 67. 3-4. This, in effect, is the faith of all physicists. The deeper we seek, the more is our wonder excited, the more is the dazzlement for our gaze. In 1974, the Pakistan Parliament made the Second Amendment to the Constitution of Pakistan that declared Ahmadis to be non-Muslim. In protest, Salam left Pakistan for London. After his departure, he did not completely cut his ties to Pakistan, and kept a close association with the theoretical physics group as well as academic scientists from the Pakistan Atomic Energy Commission. Abdus Salam died on 21 November 1996 at the age of 70 in Oxford, England, from progressive supranuclear palsy. His body was returned to Pakistan and kept in Darul Ziyafat, where some 13,000 men and women visited to pay their last respects. Approximately 30,000 people attended his funeral prayers. Salam was buried in Bahishti Maqbara, a cemetery established by the Ahmadiyya community at Rabwa, Punjab, Pakistan, next to his parents' graves. The epitaph on his tomb initially read, "First Muslim Nobel Laureate." The Pakistani government removed Muslim and left only his name on the headstone. They are the only nation to officially declare that Ahmadis are non-Muslim. The word Muslim was initially obscured on the orders of a local magistrate before moving to the national level. Under Ordinance XX of 1984, being an Ahmadi, he was considered a non-Muslim according to the definition provided in the Second Amendment to the Constitution of Pakistan.